All right, on to our solution to problem 6 from Superquiz 1. So here we're given an antiderivative and told to use a substitution to find that antiderivative. So remember the general goal we have when using substitution is to find a function in the integrand and its derivative, or at least something which is its derivative up to a constant. So when I look at this one, I notice this 5 minus t squared. And I know the derivative of 5 minus t squared is negative 2t. And hey, look up top. I have negative 2t. Well, okay, it's just the t. But the negative 2, right? Just a constant. And what do we always say? What's a constant amongst friends? So we're going to try this substitution. U equals 5 minus t squared. We compute the derivative and multiply by dt. So du will be negative 2t dt. Okay? You cannot write this expression without the dt. I mean, okay, you literally can, but it will be mathematically wrong. So if you wrote du equals negative 2t, you have written an incorrect statement because, right, we have the rule of 2, right? These d's come in pairs, or at worst, they come with an integral sign. Okay, now, we don't have negative 2t dt. We have t dt. But we could get t dt out of this, so let's just divide by negative 2. If I divide by negative 2, I'll have negative a half du equals t dt. All right, so now I can rewrite my antiderivative. First, there's this root 5 minus t squared that just becomes root u. And then t dt, that's here on the right, that becomes negative 1/2 du. All right, now to find an antiderivative, first notice this negative half, I can pull that out. And, well, it's really hard for me to do antiderivatives when it looks as it does, so I'm going to rewrite 1 over the square root of u as u to the negative 1/2. So the negative tells me it was 1 over, the half tells me it was a square root. Now I can use the power rule. And so, okay, I add 1 to the exponent, which gives me u to the 1/2. But then I have to divide by the new exponent. So I have to divide by a half, which is the same as multiplying by 2. Okay, cool. So 2 times a half is 1. There's just going to be a negative u to the 1/2, or negative the square root of u. Of course, then I'll back substitute, and I'll get negative square root of 5 minus t squared. All right, if we wanted to check this, and heck, might as well, if we wanted to check that we have the correct antiderivative, right, we just take the derivative. So let's take the derivative with respect to t, right? This is our check of negative root 5 minus t squared. Well, again, I don't like the square root sign. So let's rewrite this as negative quantity 5 minus t squared to the 1/2. When I take the derivative, first the half comes down. I get negative 1/2, 5 minus t squared to the subtract 1, negative 1/2. But then I have to use the chain rule and multiply by the derivative of 5 minus t squared, which is negative 2t. Okay, a negative a half and a negative 2 cancel. And so I'm left with t times the quantity 5 minus t squared raised to the negative 1/2 power, which is t over the square root of 5 minus t squared. Hey, that's what we were looking for.